The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everyone, and welcome to our new chapter of the IFC collaboration series of webinars that we're running on Tuesdays. We're going to give it a minute or so to let other people to join in. And in the meantime, we're just going to give you a quick reminder of what are we covering today. So today we'll continue this block of webinars where we're talking about the exchange of IFC files. In the last few parts, 1 to 3, and last time we did part 4, sort of a partial part 4, we were talking about the different methods of bringing in the files, IFC files that you have received. And we were running essentially an exercise with a structural file that was coming from Revit. Now, today we're going to talk about the same thing, but we need to cover something that we haven't talked about yet, which is the actual strategies for the exchange. So we did go through the details on what to manipulate on the translators, but not a lot more. All right, so let's keep going ahead. Again, my name is Nando Mogollon. I'm a digital consultant with Central Innovation. Remember to subscribe with all the next and following webinars through that QR code there on the screen. You can point your camera there. And right into the subject. So today we will be covering the following objectives. So we'll try to talk about the exchange strategies, and we want to talk about 2 of them, which are the main 2 strategies that I'm aware of, and the ones that you'll find in most of the literature out there. Those are going to be the so-called reference model, in which case, as you know, similar to what we used to do with paper drawings or CAD drawings in the past, we use someone else's drawing to have as a reference on the background, and then we will copy those to have our own drawings. In this case, we'll replace drawings for models, but essentially the concept is the same. So we want to go and take a look at how that looks like inside Archicad when it comes to exchanging files. And then the other one, which has been sort of the hype or the gold idea of BIM modeling, exchanging, and collaborating files, will be the integrated model. In an integrated model strategy, essentially what happens is that the models that are coming from different disciplines actually, when combined, produce a total model. So normally there's no repetition, there is no multiple versions of the same element, and instead of the models being used for reference, they actually use live or as they are. This is typically the case when you use live cloud services, and everyone is happy to work live on those models. It's a little bit tricky. It requires different contractual models, or it's better done when the contractual model actually explicitly defines the responsibilities over that integrated model. But let's go and take a look at what we mean. So we're just going to go through a couple of slides here, and then we'll jump right into Archicad and a little bit of Solibri for that sake. So let's take the example of a column, which is typically the easier to understand. A column, it's a building element that typically gets defined initially by an architect, but it's on the realm or the scope of the structural engineer. But there are different things, different aspects to the element itself, the column itself, that might be relying on different people or different companies. Typical. For a column, the architects will be worried about the finishes and its shape, right? And that's something that very likely a structural engineer won't be worried about. On the other side, the structural engineer is worried about, or heavily worried about, the construction material, because it relies on how much load can it take, and of course the size and section of the actual column, so that it can translate that into calculations and loads. Now, when those different things happen, all of them are part of the same building element. And in building information modeling, you need to be worried about as much as the shape and size and materials, as much as all the other parameters. So you can imagine there's a bunch of things in there that are not only within the scope of a single company. So what that tells you is that the scope and authority is what actually defines the strategy that you go for. So if you imagine a Venn diagram, kind of like what we have there on the screen, you'll have on one side the architectural side or the architectural scope of that one column, and then the other side, let's say, the structural scope of the same column. But the column, it's actually, in reality, it's going to be just one, right? What you need to understand is what are the aspects of the column that are coming from which source. So for instance, the location. And even prior to the location, you will be talking about the actual existence of the column itself. So if the column exists and it's located in a particular location, the architect will be worried about the space configuration given the location of the column, and the structural engineer will be worried about the entire, total integrity of the structural system, given that that one column is located at that particular point. When it comes to size and shape, that's going to affect the engineer, given that that particular size and or shape will have a specific load capacity. But the architect will be worried about that the shape will be providing a form that may or may not be aligned with the rest of the design. So the same parameter means two different things for those different people. And of course, material, which will translate into some kind of a finish for the architect, but it's also providing some sort of a strength for what it takes on the structural engineering side. So these are different aspects of what is naturally a single element, right? And that gets translated into one of the two strategies that we were talking about, depending on who is going to drive this definition of all and every single one of those parameters or properties of the single element. So let's go and take a look. Let's first talk about the reference model, which is the most used model so far when it comes to collaborating across a bunch of different files or different models. And what that means is that the single structural column, it's actually a combination of both the architectural and the structural. In that case, as is very, traditional already, the architect will put together a building that is a full building initially without too much intervention of the structural engineer other than probably some recommendations. And then out of that, we build inside that our idea of the slabs and the columns and so on, let's say the position of the columns and what we think will be the correct position of them and where they should go. So we hand that over to a structural engineer. They create their own version of that. And then the entire composition of the project during design is built up from a architectural model that contains certain structural models that will be telling something about its finishes, the overall shape, and so on, and a structural engineering model, which tells you something about the rebar and the strength of the concrete and some other properties around it, right? So that is the typical reference model, and that's very commonly used. There are different processes around it. There's different ways of coordinating that. Typically, it's a matching, trying to coordinate columns and load-bearing elements and so on. So that's fairly well known, and it's typically done in most projects. It is easier to do because it relies on a very similar process as we used to do with paper drawings. On the other side, you have the integrated model strategy. In this case, a particular element like the column generally will be just the structural column. In that case, the architects will build their own project or model based on whatever shapes they want to create, but they will need to rely on an actual structural model that comes from an engineer. So the combination of the two will form a model that doesn't have any redundancies or repetition. In that case, everything that the architect has to say about the columns needs to be handed over to the engineer so that he can make the changes. For instance, if the architect doesn't like the particular shape of a column or a series of columns in front of the building, they need to request that change to be done on the structural model, review that, give comments back so that they can get what they actually look for. That's typically what an integration of the models will mean. The architect in that case is not fully in charge of the design intention, since bits and pieces of design intention will be on someone else's scope. So their job is pretty much giving comments and trying to get those comments back. It's a lot harder to get drawings right, since you don't have control over things, over certain things, usually the shared bits and pieces of a model, like columns, but there are a bunch of other ones. So let's go and take a look. So we're going to jump right into our Archicad model, the one we've been using so far. What I have in here, as you know, we've been using this model for quite a bit, and it's essentially pretty much the same model. The only thing that we have new here will be that structural model. And what I try to do here to demonstrate the point in the two different strategies is I have on one side a model that I've got from the engineer, which they're going to produce in any case. So that's going to be this hot link. This is an IFC, as you can tell there by the hot link on the tracker. So that's a hot link bringing in IFC from Revit. And if I was using the so-called reference model strategy, what I will have, it's a model on my own that also contains certain construction load-bearing elements, but they have my own version of it. So I make a duplicate of them in a sense. So that will be this one here, for instance. And what I have there is my version of the slabs and the columns and where they should go, and probably their own size, right? If I was talking about not a reference model like such, which is a full model on its own, except for rebar and other details that we haven't talked about, then it will look pretty much like a full building. On the other side, if I was working on an integrated model strategy, the model that I will build under my scope will look a lot more like this, where I will have most of the architectural items, but most of those items will be all relying on whatever is my scope. So it doesn't mean that you're not going to have anything that will resemble columns or floors. You still have them, but they probably will be only within your scope. For instance, I still will have ceilings, I'll still have floor finishes, but I'm going to make sure that I classify those as pure flooring or pure ceiling. So there are considerations over the granularity on how do you model and what do you export from the exchange, since now you're going to have to use, rather than having a composite that takes ceilings and floor finishes into one, you probably want to build something that actually describes different layers into different element types, like ceilings and floorings. Same thing applies for columns, although the columns here, I don't have any particular finishes to them. But it might be the case that I will model just a furring or a cladding around the columns, but not the columns themselves. That will be for an integrated model. But if I'm using the reference model strategy, then I actually have columns that I have on my own layers. Let me give you a quick idea on this, although the layer list is not exemplary at all, but at least I can give you some ideas on how do I differentiate between those things. So in a case like this, things that I model inside or within the reference model strategy, I will make sure that I have those elements somehow grouped in a way that I can tell they're not under my scope. So typically I use an acronym for that. There's no magic into this. That's not a standard coming from anywhere. That's purely my own personal preference, where I go and say out of scope. So I add that to the extension of the layer. So I know that anything that I model within the OOS layers, those are things that I have for reference, but they're not really under my scope, right? Or the scope of work that I have. So I can easily switch them on and off in need, depending on what do I need to display. So that's for a three-dimensional model that you exchange. That whole thing actually has a heavy replication on the production of your drawings. So drawings or a floor plan view in the reference strategy will look something like this. And I know that these columns are my columns, even though they're out of scope, but they're mine. I can control, I can move them around if I need to, right? Or change the shape or material. I can have full control over those, therefore controlling the design intention on those. But you can also go and say, well, if I needed to have an integrated display of this, what I'll have is, instead of having my columns, I will be displaying the actual columns coming from the engineers. And if that is the case, if I wanted to move this column, I won't be able to do so. And you're going to have to resort to some of the tricks that we were showing a couple of webinars ago, where you just hide this column based on the ID that you'll find in there. You refresh the hotlink, and then you probably will like to make a copy of that and put it in the location that you like. But you can imagine that you can do that with one or a few of the elements, but it's much harder to do when you're dealing with all the columns in this floor being wrong. So depending on how much and how the contractual agreement has been done prior to your modeling efforts, then you know that you'll be able to count on the modifications of this being given to the structural engineer. Some things that will be very typical of this. When you go for an integrated model strategy, typically you rely on a very quick and very often rapid exchange of files. So basically files will be exchanged almost weekly or less than a weekly basis. If there is an offline exchange. If there is an online exchange, where you'd probably be using a design CDE that allows for hosting online IFC files, and then you can connect directly to those IFC files, then the technology will allow you to do that a lot easier, right? So the exchange is actually quite dynamic, and it can be done fairly easy. In that case, I can simply just go ahead and say, dear Mr. Structural Engineer, I don't like that column to be there. It's far too close to my curtain walls, and the frames are fixed. So can we move that or reduce the size or do whatever we need to do with these columns, and then get a feedback, get an update on that model just because of that column relatively quick. On the other side, if you don't count with that kind of technology, and rather you're counting on bi-weekly or even more than that, more separated exchange of files, and even more when the exchange is given cloud services that only allow for upload and download, but not direct linking, then that's a case where a reference model probably will give you a far better flexibility, so you can control everything. On the downside, you're going to have to keep the coordination of the two structural versions, the architectural structural and the real structural. And to do so, it's that kind of stuff that it's you can do always. You can always do that within Archicad just by overlapping the two of them. Probably won't recommend that, but can be done. Rather, I'll go jump into Solibri, where I've assembled the same things for you to look at. And in this case, what I've done is I basically have the same files we have used before. This is exactly the same building. But in this case, I've grouped these in two separate assemblies, if you like. I have an integrated model that looks like that. And what I have in there, you'll see, is the architectural version of an integrated model, which basically doesn't have redundancies, so it doesn't have the columns, because I'll be using the actual structural coming from the engineer. So if I combine the two of them, then you got a project as if it was built right now. So you can imagine that in a case like this, you won't be able to avoid things like this UFO floating here, just because it was a mistake from the structural engineer. No one saw that coming. So in this particular case, you don't have control over those things simply because the model is someone else's model. Still, you can control anything that is in your scope, but nothing that is not under your scope. So the models themselves will be a true representation of the coordination of the file at any given point in time. On the other side, you have the reference model strategy. In this reference model strategy, now you have a multiplicity of columns. So for instance, let me jump inside the file in here quickly. That's probably going to be a good example. That'll be good. And in here, I have different versions of the different elements. That's why you can see the image going, the color of the slabs going a little bit weird there. Probably more explicit here in the columns, which I did intentionally. So what we have there is columns that are coming from the architectural model. These are these smaller columns here. And let's say that in this particular case, the architect assumed the columns could be just as small, 300 by 300, I think they are. And on the other side, the structural model actually replaced those, define those to have a much bigger section. These ones are for 50 by 300. But in reality, what is happening is that you have two versions of the same thing that need to be coordinated. That is what it's the reference, what the reference model means. And then it is the job of whoever is coordinating the file, typically the architect in reference model strategy. It's a matter of them reviewing all of those changes coming from the structure engineer. Say, yeah, I can work with those columns. If they need to be that big, I'll work with them that way. So I'm going to resize mine and so on while the coordination happens. At the end of the day, this is remember, all we're doing here is for the sake of the exchange, meaning that we are still within the design process, and it will be a different thing at the end when you're delivering, if you have to deliver an as-built project. When it comes to delivering the as-built project, it is very likely, although you have to review that on whatever contracts you may have. Let me see if I can. It is very likely that your entire model will end up being an integrated model, in which case you're not going to have the duplication because it should be included inside the contractual scope of the structural engineer, that their columns or any load-bearing elements will also take into account any architectural comments, like the finishes, if the finish is applied directly to the column and not through a cladding or some other element, but also parameters that may need to be included, like the fire rating, the load bearing, etc., etc., etc. So it really relies on what the contract says about that. So don't just decide whether you're going to go for integrated or reference model just because you like it. There's a lot of work behind that, and that all of that work for coordination and checking needs to be remunerated. So that's why it needs to be included on a contract. That's pretty much what that is. In any case, the models you export are pretty much the same. The only difference will be that the integrated model, when it comes to architecture, it won't have redundancies, while the reference model does have the redundancies because you want to drive the design intention on those redundant elements. All right, so that's pretty much the content we have for today. So we're getting pretty close to the end of today's presentation. If you guys have any questions, please let me know now. We still have about 5 minutes if we need to go through this. And if you don't have any questions, I have a question for you. So with this webinar today, we wrap up the exchange, and then we're going to jump into coordination, the part of the webinars that we're going to talk about coordination itself. Now, because this is supposed to be about Archicad and not about Solibri, I'm going to try to focus as much as I can within the limits of what Archicad can do. But there is some limit to that. If you have any say about if you want to see some of that in Solibri, please let me know through the question panel on GoToWebinar. So if you think that Solibri plays a part and you want to see how much can be done within it, let me know right away, and we'll try to include that in the following webinars. Next webinar, it's next Tuesday again at around 11 or 11:30. I need to double check that because there are some changes in time there that are not under my control. But we'll try to keep you posted on that. And with that, that's pretty much what we have for today. Remember, you have access to your support center through MyCI, or for general inquiries through your account manager emails there on the screen for both Australia and New Zealand. Thank you very much for your time, guys. Have a nice day, and we'll see you next week. Thank you.